Hello all, this is Sandeep Kumar and I welcome you back to my YouTube channel Math with Sandeep. We are in the chapter of differentiability. Already we have completed the concepts of continuity along with the problems on it. So now we are in the chapter of differentiability. So in today's video, let us discuss about differentiability of a function at a given point and at the same time differentiability of a function in a given interval. So we will see how to define differentiability, and after that we will see when does the derivative of a function at x is equal to a exists. So we will generally think that f dash of x always exists, but that is not the case. So okay, we will see when does f dash of a exists. Okay now, so based on this particular condition. So this is called left hand differentiability and this is called right hand differentiability, and these two are the formulae of those two. Okay now, so we will discuss clearly of what is the meaning of differentiability of a function at x is equal to a, and we will see when the function is differentiable at x is equal to a, and after that we will see the graphical interpretation of f dash of a on the graph. Okay now, how do we understand it graphically, and at the same time we will also discuss problems on it. Okay, first let us see what is the definition of differentiability. How do we understand the concept of differentiability? Okay, let us start. But if you are new to the channel, don't forget to subscribe the channel. Okay, and anyhow let us start. Okay, let us see the definition of differentiability. To understand that, first let us consider a function y is equal to f of x and let us draw its graph. So this is some random function y is equal to f of x and this is its graph. You can draw any shape. Observe one thing, at x is equal to a, clearly the function is continuous. You can draw the function continuously without lifting the hand. We are trying to find what is the slope of the curve. But observe one thing, dear students, these kind of curves have different slopes at different points. So what exactly is a slope? For example, I want to know what is the slope of the curve at this particular point where the input is x is equal to a. Okay, so the definition of a slope of a curve at this point is given by the slope of its tangent at this point. Okay, so at this point you draw a tangent. You already know what is tangent. Tangent is a line which touches the curve at this one particular point. Okay now, so draw a tangent at this point to the curve. Now the slope of the tangent is nothing but the slope of the curve. The slope of this particular tangent at x is equal to a is same as slope of the curve. So slope of the curve at x is equal to a is same as, what is it dear students, is same as slope of the tangent at x is equal to a. So in the upcoming chapter differentiation we will clearly discuss few more concepts about it. For now you just accept that the slope of this particular tangent is nothing but f dash of a. Okay, so what is f dash of a? F dash of a is the slope of the tangent. Slope of the tangent to this curve. Slope of the tangent to this curve at x is equal to a. Okay now, so why exactly we call this as slope of the tangent, we will learn very soon when it comes to the chapter of differentiation. Okay now, so f dash of a is the slope of the tangent at x is equal to a. Therefore we can also say that f dash of a is the slope of the curve at x is equal to a. Okay now, but you should know what is the formula for f dash of a, right? And f dash of a we actually call it as derivative of y is equal to f of x at x is equal to a. So we call f dash of a as derivative of y is equal to f of x at x is equal to a, and the formula to find this derivative f dash of a is limit h approaches 0 f of a plus h minus f of a divided by h. Remember this, the formula to find f dash of a is limit h approaches 0 f of a plus h minus f of a divided by h, or we can also use another formula, limit x approaches a f of x minus f of a divided by x minus a. I can either use this formula to find f dash of a, or I can use this formula to find f dash of a. For now, let me concentrate on this particular formula. Dear students, please observe one thing. We say that derivative of the function y is equal to f of x at x is equal to a exists if f dash of a is a finite number. Remember this, f dash of a must be a finite number. In that case, we say that the derivative of y is equal to f of x exists at x is equal to a. But when can I say that f dash of a exists particularly? When can I guarantee a finite number here? Means, please observe, f dash of a is clearly a limiting value of a function. F dash of a is clearly a limiting value of a function. We already learned that limit exists if left hand limit is equal to right hand limit. Okay now, so now let us observe that. Now let us stress on when does f dash of a exists. Okay now, so dear students, f dash of a exists and it will be finite when means if f dash of a exists if f dash of a plus is equal to f dash of a minus. Now what is f dash of a plus? So f dash of a plus is given by limit h approaches 0, f of a plus h, because it is a plus na. So a plus h minus f of a divided by h. And what is f dash of a minus? F dash of a minus is given by limit h approaches 0. See, it is a minus, right? So f of a minus h minus f of a divided by minus h. Please observe, minus is there here, minus h. Okay now, so this is f dash of a plus. It is also called as LHD. What is LHD? Left hand differentiability. And f dash of a minus is called RHD. RHD means right hand differentiability. Dear students, if the left hand differentiability is equal to right hand differentiability at x is equal to a, then we say that f dash of a exists. But observe one thing, this value should be a finite number. It should not be infinite. Keep this in mind. And f dash of a minus also should be finite. The left hand differentiability and right hand differentiability, they must be finite, and at the same time they must be equal to each other. If that is the case, we say that f dash of a exists, and hence we can say that f of x is differentiable. F of x is differentiable at x is equal to a. So what is the meaning of this statement, dear students? What is the meaning that f of x is differentiable at x is equal to a? It means that f dash of a exists. F dash of a is a finite number. Please observe, it should not be infinite. Okay now, so when f dash of a plus is equal to f dash of a minus, let us assume that the answer is k, where k is a finite number. Then we say that f dash of a exists and f dash of a is equal to k. Okay, so remember this while solving the problems. If they are asking us to check whether the function is differentiable at x is equal to that particular number or not, we will find the left hand differentiability, we will find the left hand differentiability, we will find the right hand differentiability, and we will check whether both answers are finite answers or not, and if both are equal or not. Okay now, if both are equal and finite, then we say that f dash of a exists and therefore the function is differentiable at that particular point. Okay, now before continuing with the next concept, let us see what is the geometrical meaning that f dash of a exists. See, dear students, already I told you, yes, f dash of a exists and is finite. So geometrically, what is the meaning of it? Already I discussed it that f dash of a is what, dear students? It is the slope of the tangent to the curve at x is equal to a. So if this is the curve and this is the tangent at x is equal to a, okay now, so then f dash of a is what? It is the slope of this curve, slope of this particular this particular tangent or slope of the curve. Okay, whatever it is the slope of this tangent at x is equal to a. So if f dash of a is finite, we can say that there is only, what is it? We can say that we can draw a unique tangent. We can draw unique tangent at x is equal to a, and that particular tangent has a slope called f dash of a. So f dash of a exists or a function is differentiable at x is equal to a means geometrically what is the meaning of it? It means that at x is equal to a, I can draw a unique tangent to the function y is equal to x. Unique means one. Okay, one and only one. So that is the geometrical meaning of it. Okay, now let us try to understand the relation between continuity and differentiability. And I already told you, please observe one thing. I told you at the starting that at x is equal to a, the function is continuous. You can draw the graph of the function continuously without lifting your hand. Correct or not? So keep this in mind. A function is differentiable only when a function is differentiable. Okay, we can check differentiability. Let me say like this. If you want to check the differentiability of a function at x is equal to a, first of all, it must be continuous. We can check the differentiability of only a continuous function at x is equal to a. At x is equal to a, if the function is not continuous, obviously the function is not differentiable. Dear students, we will check the differentiability of only continuous functions. Keep this in mind. Okay, now let me give more clarity about it. This is the most important point when it comes to differentiability. We will use this particular point while solving the problems. So what is it? For a function to be differentiable at x is equal to a, it must be continuous at x is equal to a. Dear students, keep this in mind. So as I told you, only when a function is continuous at x is equal to a, only then I can be able to draw a tangent here. Correct or not? What if a function is not continuous at x is equal to a? Assume this is the function's graph. Please observe, at x is equal to a, if you look at this particular graph, at x is equal to a, the function is not continuous. Correct or not? How can you draw a unique tangent at x is equal to a? How can you draw a unique tangent at x is equal to a? Some students will say, sir, shall I draw like this? No, you can also draw like this. You can also draw like this. Please observe. Multiple possibilities are there. We cannot draw a unique tangent at x is equal to a to this function. Okay, now. So therefore, here in this case, the function is not differentiable, because we are unable to draw a unique tangent at x is equal to a to the function. I'll discuss this point once again later. So dear students, what is it? First of all, for a function to be differentiable at x is equal to a, it must be continuous. And if the function is not continuous at x is equal to a, it is not differentiable. If a function is not continuous at x is equal to a, then obviously it is not differentiable at x is equal to a. So while checking differentiability in many questions, first we will check whether a function is continuous or not at x is equal to a, and after that we will go for differentiability. Okay, now so anyhow, keep this in mind. Now next, let us see what is next. Look at this particular point. If a function is differentiable at x is equal to a, okay, we have observed that a function is differentiable at x is equal to a, then we can say that, then we can guarantee that the function is continuous at x is equal to a. Remember, if the function is differentiable at x is equal to a, it is continuous at x is equal to a. Keep this in mind. Okay, now if you want me to prove this, so what is it, dear students? If you want me to prove this, please observe that the function is differentiable at x is equal to a. What is the meaning of it? It means that f dash of a is finite and exists. F dash of a is finite and it exists. And what you are supposed to prove here, that it is continuous at x is equal to a. If the function is differentiable at x is equal to a, then we have to prove that the function is continuous at x is equal to a. Let us see how to prove it. A simple proof itself, so I am giving it. See, if you want to prove that function is continuous at x is equal to a, means you should prove that the limiting value of the function is equal to value of the function. Correct or not? If limit x approaches a, f of x is equal to f of a, then the function is continuous at x is equal to a. So using this information, if you can prove this, then the statement is true. It's very simple statement. What I am going to do for this is, let me consider limit x approaches a, f of x minus f of a. Let me consider this particular mathematical term, okay, which is equal to limit x approaches a. Dear students, I am going to multiply the numerator and denominator with x minus a. So the numerator is multiplied with x minus a and the denominator is also multiplied with x minus a. Dear students, at the starting of the video I told that this is the formula of f dash of a. Okay, fine. But the limit also belongs to this, correct or not? So it is equal to limit x approaches a, x minus a. And now here I can substitute x as a. I can substitute x as a. So a minus a is 0. 0 into anything is 0. Please observe that f dash of a exists and finite. So 0 into a finite number is 0. So therefore, dear students, we can transpose minus f of a to the right side. So what do we get? Limit x approaches a, f of x, and minus f of a is a constant. It is independent of the limit. You can take it right side, is equal to f of a. So we have proved that the limiting value of the function is equal to value of the function. So this means that the function f of x is continuous at x is equal to a. If the function is differentiable at x is equal to a, I have proved that the function is x is equal to a. The function is continuous at x is equal to a. So if it is differentiable, then it is continuous. Now, what is the converse of it? Can I say that if it is continuous, it is also differentiable? No. If it is continuous, we cannot guarantee that it is differentiable. So it means that when a function is continuous at x is equal to a, it may be differentiable or it may not be differentiable. And let me take an example to prove that even though the function is continuous at x is equal to a, it is not differentiable. Okay, let me write that statement. So look at this statement. If the function y is equal to f of x is continuous at x is equal to a, it may or may not be differentiable at x is equal to a. So we cannot guarantee differentiability. When a function is continuous, we cannot guarantee the differentiability. So which means that a continuous function may be differentiable at x is equal to a or may not be differentiable at x is equal to a. We can find examples where it is differentiable. Here I would like to give you one particular example where the function is continuous but not differentiable at x is equal to one particular number. For this, let me take f of x equal to mod x, and let me check whether it is differentiable or not at x is equal to 0. So check differentiability at x equal to 0. Okay, let us see whether the function f of x is equal to mod x is differentiable or not at x is equal to 0. But before that, let me check whether it is continuous or not. So though already many of you know that it is continuous, but anyhow let me prove it. Okay, first let us check continuity. After that we will check differentiability. First let us check continuity. Let us check whether the function is continuous or not at x is equal to a. So left hand limit f of 0 minus is what, dear students? So it is limit h yes, or let me write limit x approaches 0 minus mod x. So what is it, dear students? It is limit h approaches 0 modulus of, and instead of x we will write 0 minus h, correct or not? That means what? Minus h, where h is positive and approaching 0, where h is positive and it is approaching 0. So and modulus of minus h is plus h, or we can directly substitute h value as 0 now. H value as 0, modulus of minus 0 or plus 0 is equal to 0. The left hand limit is 0. Similarly, the right hand limit also you can find f of 0 plus, which means limit x approaches 0 plus mod x. So which means limit h approaches 0 modulus of x is equal to what, dear students? X is 0 plus h, correct or not? So instead of x I can substitute h. Now I will substitute h value as 0. So modulus of 0 is 0. So the left hand limit is 0, the right hand limit is 0, but that is not enough. We should also see what is the value of the function. F of 0 is what? Mod 0, which is equal to 0. Observe, all three are equal to 0. Correct or not? So in this case we got f of 0 plus is equal to f of 0 minus, which is equal to f of 0. The left hand limit at x is equal to 0 is same as right hand limit, which is same as value of the function. So therefore we can conclude that the function is continuous at x is equal to 0. So what is the conclusion, dear students? The function is continuous at x is equal to 0. Now the function is continuous at x is equal to 0. That does not guarantee that the function is differentiable at x is equal to 0. Let us see whether the function is differentiable at x is equal to 0 or not. So to check differentiability, first let me find the right hand differentiability. F dash of 0 plus RHD. I am first finding RHD, right hand differentiability. F dash of 0 plus. And the formula is limit h approaches 0 f of 0 plus h minus f of 0 whole divided by h. So which is equal to limit h approaches 0. What is f of h? If f of x is mod x, then f of h is mod h minus, students, f of 0. f of 0 is mod 0, which is 0 divided by h. So all of us know that h is already positive. So mod h is h divided by h, which is equal to 1. So I got RHD as 1. Let me see what is LHD. Okay, the left hand differentiability. Here itself I will do it. So in the same step, I got right hand differentiability as 1. Let us see what is LHD. So the left hand differentiability is f dash of 0 minus. 0 minus means what? Limit h approaches 0, f of 0 minus h minus f of 0 divided by minus h. Some of us will keep forgetting minus h in the denominator for LHD. Please observe, it is minus h in the denominator. So f of minus h. f of minus h is modulus of minus h. Correct or not? So it is modulus of minus h. f of 0 is 0 only. f of 0 is 0 divided by minus h. Please observe one thing, dear students. Modulus of minus h is plus h. But denominator has minus h. And h divided by minus h is minus 1. Dear students, the left hand LHD, the value of LHD is minus 1. Both are finite, but they are not equal. Left hand differentiability is not equal to right hand differentiability. For this reason, f dash of 0 does not exist. And since f dash of 0 does not exist, we can say that the function f of x is equal to mod x is not differentiable at x is equal to 0. The function mod x is not differentiable at x is equal to 0. Do you observe one thing here? At x is equal to 0, this is continuous but not differentiable. This is one particular example where it is continuous but not differentiable. There are functions which are both continuous and also differentiable. We will discuss it in problems. Okay, but keep this in mind. When a function is continuous at x is equal to a, it may be differentiable at x is equal to a, or it may not be differentiable at x is equal to a. Okay, so fine. Now let us check the reasons. What are the various reasons for which a function is not differentiable at x is equal to a? Okay, there are three reasons for a function to be non-differentiable at x is equal to a. The first reason is that at x is equal to a, the function is not continuous. Over. At x is equal to a, if the function is not continuous, you cannot draw a unique tangent at x is equal to a. You cannot draw a unique tangent, as I have told you already. See, one student will draw a tangent like this, another student will draw a tangent like this. You cannot draw a unique tangent at x is equal to a. Okay, now for this reason we say that the function is not differentiable at x is equal to a. So what is the first reason? If f of x is not continuous at x is equal to a, then obviously it is not differentiable. Okay, now this is the first reason for a function to be non-differentiable. And what is the second reason? It is observed that the function is continuous. What is it, dear students? F of x is continuous at x is equal to a. At x is equal to a, the function is continuous, but still, what is it? The right hand differentiability is not equal to left hand differentiability. Please observe, both RHD and LHD are finite, but they are not equal. So if LHD is not equal to RHD, then we say that the function is not continuous. Already in the previous example where we have taken f of x is equal to mod x, we observed that the right hand differentiability is plus 1 and the left hand differentiability is minus 1. They are not equal in the previous example. I have drawn the graph also for y is equal to mod x. Please observe, at x is equal to 0. What did you observe at x is equal to 0? If you draw the graph of y is equal to mod x, this is the graph of y is equal to mod x. At x is equal to 0, what do you observe? We can see a sharp turn at x is equal to 0. Correct or not? So whenever, dear students, whenever the graph of y is equal to f of x has a sharp turn, At that particular input, the derivative does not exist. That means the function is not differentiable at the inputs where the graph has a sharp turn. See, y is equal to mod x graph is this. It has a sharp turn at x is equal to 0. So at that particular input, the function is not differentiable. So we can conclude that if the graph has a sharp turn, then at those inputs, the function is not differentiable. Okay, now, so remember this is that particular case. So whenever the graph has sharp turn, it at those points the left hand differentiability will not be same as right hand differentiability. The left hand differentiability will not be same as right hand differentiability. They are finite, both are finite, but they are not equal. Okay, in that case also we can say that f of x is not differentiable. That is the second reason. So okay, now what is the third reason? The third reason for a function to be non-differentiable is that either RHD or LHD or sometimes both are not finite. Please observe this. Left hand differentiability must be finite. Right hand differentiability must be finite. Okay, now if they are not finite, the function is not differentiable at x is equal to a. Okay, now see, if you see the graphs of the functions where one of these persons is not finite, we can observe a vertical tangent at x is equal to a. If you see the graph of it, let me show you a simple example for that. Here is the graph of one such function. At x is equal to a, the graph has a vertical tangent. Okay, now, so in these kind of cases, either the right hand differentiability will not be finite, or the left hand differentiability will not be finite, or both of them will not be finite. In those kind of cases also, we will conclude that the function is not differentiable. That means f dash of a does not exist. That is what we conclude. Okay, now there are three reasons for non-differentiability. If the function is not continuous, it is not differentiable. Or if LHD is not equal to RHD, then the function is not differentiable. Remember, both are finite, but they are not equal. The function is not differentiable. And if the function, if either RHD is not finite, or if LSD is not finite, or if both of them are not finite, then also the function is not differentiable. In these two cases, f of x is continuous but not differentiable. Okay, now, so these are the three main reasons, or these are the three only reasons for a function to be not differentiable. Okay, now let us discuss a simple concept, differentiability. See, until now we discussed differentiability of a function at a point. Now let us discuss what is differentiability of a function in an interval. Okay, differentiability of a function in an interval from, okay, dear student, there is important point. Generally we check continuity in closed interval a comma b and differentiability in open interval a comma b. We will not check the differentiability at the endpoints. Please observe this, because for example, let me draw the function from x is equal to a to x is equal to b, some random function. Okay, now, so please observe the one particular thing, dear students. We can draw the function continuously from a to b. But while we are checking differentiability, okay, now, we cannot say that the function is differentiable at x is equal to a. We cannot check it, because differentiability at x is equal to means what? The possibility of drawing a unique tangent at x is equal to a. But generally we know that at the endpoints, how will you draw a unique tangent? Is it possible to draw a unique tangent? Will you draw like this, or will you draw like this, or will you draw like this? We don't actually check differentiability of a function at endpoints in an interval. So I will not check differentiability of a function at x is equal to a or x is equal to b. So I will be checking the differentiability of a function only between a and b. Keep this in mind. But continuity can be checked from a to b. Okay, now we already discussed that a function is continuous at x is equal to a if it is right continuous at x is equal to a and if it is left continuous at x is equal to b. Already we have discussed directional continuity, correct or not? But when we are talking about differentiability in an interval, we will choose only a open interval a comma b, not the closed interval a comma b. So, and dear students, a function y is equal to f of x is differentiable in open interval a comma b if it is differentiable at all x between a and b. That means what? Between a and b you take any input, you take any number between a and b. For example, c. At this point it must be differentiable. It must be differentiable means what? We must be able to draw a unit tangent. Okay, now at any point between a and b you take a point. At that particular point it must be differentiable. So which means between a and b there are infinite points, and at all those infinite inputs the function must be differentiable. In that case we say that the function is differentiable in open interval a comma b. So at every input between a comma b the function must be differentiable. Then we say that it is differentiable in open interval a comma b. So this is the meaning of differentiability of a function in an interval. Okay, now let us solve some problems based on this. And before that, a small note, dear students, an important note. Look at these 6 type of functions: polynomial functions, logarithmic functions, exponential functions, rational functions, trigonometric functions, and inverse trigonometric functions. Dear students, we have already discussed that these functions are continuous in their domain. And at the same time here I am also going to tell you that all these functions are also differentiable in their domain. They are differentiable. All these functions are differentiable in their domain. Okay, now so all these functions are differentiable, not only continuous, they are also differentiable in their domain. Remember this, sometimes we will use it directly while solving the problems. Okay, now let us start solving few questions based on differentiability. Here is our second question, because already in first question we proved that mod x is not differentiable at x is equal to 0. Okay, here is our second question. They told us to check the differentiability of f of x is equal to mod of log x base e at x is equal to 1. Actually, before checking differentiability we will check continuity, but already we know that the logarithmic functions are continuous in their domains. So we will accept that this particular function is continuous at x is equal to 1. Okay, it is a logarithmic function, it is continuous. Let me check whether it is differentiable or not at x is equal to 1. Okay, for this first let me find the right hand differentiability RHD. Dear students, RHD is equal to limit h approaches 0 f of a plus h. What is that a value here? 1. F of 1 plus h minus f of a, that means f of 1 divided by h. So limit h approaches 0, f of 1 plus h means what, dear students? Mod of log of, instead of x we are writing 1 plus h. Instead of x we are writing 1 plus h. Close the bracket, minus f of 1. F of 1 means mod of log 1. And you already know that log 1 is 0, whole divided by h. So limit h approaches 0. Log 1 is 0, we can ignore this, minus 0 is not needed. And since h is positive, let me take whole modulus of log of 1 plus h divided by h. Dear students, in logarithmic limits we already learned that when h approaches 0, log of 1 plus h divided by h is 1 with modulus. So the answer is 1. What answer? The right hand differentiability. You have found only right hand differentiability, which is equal to 1. Similarly, you can find left hand differentiability. I'll do it here itself. Okay, now I got RHD as 1, the right hand differentiability, which means f dash of 1 plus. So it is equal to 1. Now let me find what is LHD, the left hand differentiability. What are the changes in the formula? So it is not 1 plus h, it is 1 minus h. This is same, and it is not plus h, it is minus h, correct? So f of 1 minus h, what is f of 1 minus h? Mod of log of 1 minus h, mod of log of 1 minus h. So this is as it is divided by minus h. Dear students, let me take minus outside, and this is what the numerator is, mod of log of 1 minus h. Okay, now I took minus outside now. Since I took minus outside, here we have only h, and I can write h as mod of minus h. Yes, because mod of minus h is plus h, which is equal to h only. Mod of minus h is h. So for that reason, so what I did here, dear students, so this will become 0. Mod of log of 1 minus h divided by mod of minus h is single modulus of this, correct or not? Where the minus is outside. Once again, when h is approaching 0, minus h is also approaching 0. So limit minus h approaches 0. Log of 1 minus h divided by minus h is also 1 only, with minus sign outside. So the answer is minus 1. Please observe this. Answer is minus 1. Okay now, so the left hand differentiability LHD is equal to f dash of 1 minus, which is equal to minus 1. So RHD is not equal to LHD. The left hand derivative is not equal to the right hand derivative. So what is the meaning of this, dear students? What is the conclusion? The function f of x is not differentiable at x is equal to 1. Not differentiable means f dash of 1 does not exist. F dash of 1 does not exist. I hope you understood this particular step. First I took minus outside, then I have written h as mod of minus h, then I took a single modulus, then I have used logarithmic limits, and I got the answer. Okay now, so LHD is not equal to RHD, therefore the function is not differentiable. Okay now, let us go for next question. Before solving the next question, this is the graph of the previous question. Y is equal to mod of log x base e. Look at this. This is the graph of mod of log x base e. At x is equal to 1, the graph has a sharp turn. Can you see it? The graph has a sharp turn. And that is the reason why the function is not differentiable at x is equal to 1. So if you know how to draw the graph, just by drawing the graph also you can say that the function is not differentiable at x is equal to 1. But please observe, at other points between 0 and 1 or between 1 and infinity, there is no sharp turn anywhere. The function is continuous and without any sharp turns. At other points it is differentiable, but not at x is equal to 1. Okay now, so fine, we'll go with next question. Third question. Here is a question which you can try. The function is f of x is equal to mod of x cube. It is a polynomial function. We already know that it is continuous, so no need to check for continuity. You only check whether it is differentiable or not using x is equal to 0. Okay, now at x is equal to 0. Find the left hand differentiability LHD and also RHD. If both are finite and if both are equal, you can say that it is differentiable at x is equal to 0. And if they are not equal, it is not differentiable at x is equal to 0. So dear students, will you try this question? So please do it and let me know what is the answer that you have got for third question. What is LHD? What is RHD? Is the function differentiable or not? Let me know in the comment sections. Okay, let us solve fourth question. Let us see what is fourth question. This is for you to try. Dear students, they told us to discuss the differentiability of this particular function at x is equal to 4 by 3. Okay now, so you can check whether the function is continuous or not. Obviously it will be continuous, so I'm directly going for differentiability, but actually you are supposed to check continuity also at x is equal to 4 by 3. Since I know that it is a continuous function, I'm just going for, because root of f of x is continuous. Generally, if f of x is a polynomial, remember, if f of x is a polynomial, then root of f of x is continuous in its domain. In the domain of root of f of x, this is actually continuous, but remember f of x is a polynomial. Okay now, so based on that, I'm just not only root, any power of, okay now, particularly positive rational power, not negative rational power. Okay now, so some nth root of f of x is continuous in its domain if f of x is a polynomial. Okay, fine. Let us directly check whether it is differentiable or not. For this, I'll do the right hand differentiability RHD, which is f dash of 4 by 3 plus. So which is limit h approaches 0, f of 4 by 3 plus h minus f of 4 by 3 whole divided by h. The right hand differentiability. Dear students, limit h approaches 0. If this is f of x, then what is f of 4 by 3 plus h? F of, I want to find 4 by 3 plus h. So in place of x, you can substitute 4 by 3 plus h. It is 3 times. Instead of x, I am taking 4 by 3 plus h. 4 by 3 plus h. Okay, now, so 3 times 4 by 3 plus h minus 4 whole power 3 by 5. F of 4 by 3 plus h is this. So instead of x, we have written 4 by 3 plus h. Okay, now, minus f of 4 by 3. Try to find what is f of 4 by 3. It is 3 into, instead of x, we have taken 4 by 3 minus 4 whole power 3 by 5 whole divided by h. Dear students, into 3 by 3 will get cancelled. 4 minus 4 is 0. 0 power 3 by 5 is also 0. So this term is gone. And take 3 inside, multiply with both the terms. What do we get? Limit h approaches 0. 3 into 4 by 3 is 4. Plus 3 into h is 3h. Minus 4 whole power 3 by 5. Minus 0 is not needed. Whole divided by h. Plus 4 and minus 4 will get cancelled. And I can take, what is it? It is equal to limit h approaches 0. 3h whole power 3 by 5 is 3 power 3 by 5 into h power 3 by 5. 3h whole power 3 by 5 is this divided by h. 3 power 3 by 5 you can take it outside. 3 power 3 by 5 into limit h approaches 0. This is what, dear students? H power 3 by 5 divided by h power 1. It is 1 divided by h power 1 minus 3 by 5. Correct or not? I just took it to the denominator here and I used a power m divided by a power n. Okay. So you will get 3 power 3 by 5 into limit h approaches 0. 1 divided by h power 2 by 5. Now if you substitute h as 0, I am getting 1 by 0 point something whole power 2 by 5. This is taking plus infinity. This is approaching what value? Plus infinity. Dear students, the right hand differentiability RHD is not finite. Since RHD is not finite, according to our definitions, we say that the function is not differentiable at x is equal to 4. So f of x is not differentiable at x is equal to 4 because RHD is not finite. We got infinite value. Okay, it is not finite. Okay, and we can also say that f dash of 4 by 3 does not exist. Sometimes in problems they will ask us to find f dash of 4 by 3. So these are few questions on the introduction, basic introduction of differentiability, dear students. In the next video, let us discuss more problems on differentiability of the functions. Okay, now, so I hope you have understood the concept of differentiability clearly, and you have also understood how to use it and how to solve the problems. So in case if you have understood this concepts, do like the video, share it with your friends, let the channel grow. See you all in the next video, dear students. This is Sandeep Kumar. Take care.